can see I have shared the screen. Okay. So we completed the parallel axis theorem and perpendicular axis theorem. Also, we completed the radius of gyration, right?
Yes, sir, we completed it. Yeah.
Okay. Now, here you have to understand that moment of inertia depends on the mass and the distribution of mass about the axis. Here you can see that if the shape of the body remains the same, then its moment of inertia formula will remain the same. So better you can do some questions, then you will understand. So 1 minute. Okay, discussed these things. So let's directly come to the torque now. Directly come to the torque. Can you see on the screen torque is written?
Yes, sir, I can see, sir.
Okay, so now we are going to talk about the torque. Okay, here you have to understand that in translational motion, we already studied that when force acts on a particle, it produces linear acceleration. Okay, so just like the force produces linear acceleration, similarly, torque produces angular acceleration. So torque is the rotational analog of the force. So the role that force play in translational motion, similar role is played by torque in rotational motion. Now, what is torque? First of all, torque is the rotational effect produced by a force. For example, you can see that here is a rod. You can see this is a rod, and on this rod, a force is acting. You can see this is the force acting on the rod, right? And the rod is hinged, is not free. The rod is hinged about one of its end. This rod can only rotate. Okay. So when you will apply this force, what do you think? What will happen? The rod will rotate, not rotate. Talking about this situation. Don't think about physics. Think practically. There is a rod, and you will apply a force like this. What you will observe? Think practically.
It will rotate, not rotate.
So the rod will, you will see that it will start rotating. Okay. So this force that is acting on the rod is producing a turning effect, a rotational effect. This turning effect produced by the force is we call as torque. So torque is produced because of the force, because torque is the turning effect produced by the force. Okay. Now here you can see that this force we can break it into two components. One component is this, which is perpendicular to the rod. Okay. And there is another component which is along the rod. Now, again, if you will think practically, you will understand that this component of the force cannot rotate the rod about this end, right? Because this component of force, if you will think practically, and if you apply a force on the rod along the rod, you cannot, this force cannot rotate it. But the other component, this component of the force, will be responsible for rotation. So the component F sine theta is producing the turning effect, means is responsible for producing the torque. Now let's come to the general definition of the torque first. Okay, general definition of the torque, mathematical definition of the torque. So suppose that there is a body, and on that body some force is acting at a particular point. So suppose force is acting here. If you see carefully, you will see the point of application of force is this point. Here force is acting, right? And now you have to find what is the rotational effect produced by that force about this point, point O. So that is called as the and a torque about point O. To understand this, you can again imagine that there is a rod here, you know, there is a rod, and on that rod some force is acting here at point P. So now the question is, find the torque due to that force about this point. So now how it is defined, how the torque is defined. Torque is simply mathematically defined as cross product of r vector, this is your r vector, and f vector, this is f vector, this is force vector. Now here you have to understand that torque is always defined about a point or about an axis, and torque about a point is given by vector r cross f, where r, you have to understand very carefully. Most of the time students make mistake in understanding this r. F, they understand that f is the force vector. What is r vector? So r vector is the vector drawn from the point where you have to find the torque to the point of application of the force. Vector drawn from the point where you have to find the torque to the point of application of force. So here you can see that this r vector is drawn from O to this point P. Okay, so this is a vector which is joining the point where we have to find the torque to the point of application of the force. Torque is simply r vector cross f vector, cross product of two vectors. Okay, as you know that it is cross product of two vectors, so its direction will be perpendicular to the plane containing r vector and f vector. Okay, now if you simplify it, you will get rf sine theta. So the magnitude of torque,
Sir, its direction is perpendicular to the uh, plane containing both vectors, means the turning effect should be in that direction perpendicular to the plane, no, sir.
no,
And then the torque means the turning effect only we call as torque, no, sir.
axis, along the axis. So when I say turning effect, then if you think that turning effect is what do you understand by turning effect? Like you are saying, no, turning effect should be in perpendicular.
So I mean, generally we say that torque is the turning, no, sir. Means the turning
Torque
effect
is
is called torque.
torque is defined as the turning effect produced by the force. Okay.
So then direction of torque means we can say it's the direction of rotation only, means the
So
direction
there
of
is,
turning.
yeah. So if you are saying is in the direction of rotation, now just explain what you mean by direction of rotation. There is nothing called as direction of rotation, first of all. There is direction of angular velocity. If that is you consider as direction of rotation, then yes, torque will be in the direction of the angular velocity in this case. First of all, you have to understand what you are talking. You are saying, no, direction of rotation. What is the meaning of direction of rotation? If something is rotating in XY plane, that is not the direction of rotation.
No, sir. Angular velocity direction it is.
So you will have to be precise. That is also not the direction of rotation. That is the direction of, you can say that is the direction of the angular velocity. And torque will not be in the direction of angular velocity always. In this situation only, because it is starting from rest. That's why. Are you getting? So if you will understand things like this, you will get confused. You should be very, very clear. Very clear. There should be not a single confusion. So here you have to understand that the direction of torque is always perpendicular to r vector and f vector, and and you can say that it is perpendicular to the plane of rotation. It will be perpendicular to the plane of rotation.
Sir, what
So
is
if,
the real meaning of torque, sir?
sorry,
Sir, what is the real it, torque means basically the turning effect, no, sir,
this
produced
is
by
this
force.
is torque. This is the real meaning. So torque is simply the turning effect that is produced by the force. So suppose there is a body, anything you can imagine, any body you can imagine. And so this is the body, suppose. And the question is that you have to rotate it about, and let's hinge the body to keep things simple, because if you will not keep it hinged, then it will be, rotation will be also there, translation will be also there, so it will be more complicated. So then for the time being, just hinge the body. So suppose the body is hinged about this point, there is a nail passing through this point, so the body cannot move, it can rotate about this only. Now to rotate this body, so when I say rotate means to what, how we will say that there is rotation or not. So if there is angular velocity, right?
Yes, sir. Angular
If there
velocity.
is, so if it is at rest, then it is not rotating because angular velocity is not there.
Yes,
So to bring it from rest to motion, what is required?
and force is required.
So force is not required. First of all, you have to understand. Force is required, but only force is not required, because see, I am applying a force, but can the body rotate about this point in this situation? Tell me.
Sir, no, sir.
Yes. So from here it is clear that yes, force is required, but it is not the force only. Are you getting? There is something else. That something else depends on force, and that is called as torque, which can produce rotation. Force, if it is only the force and no other parameter, then there will be no quantity like torque. Okay, torque is there because yes, force is required to produce rotation, but it is not only the force, it is the force, and the point of application of force also matters, that where you are applying the force. Are you getting?
Yes,
Force
sir.
can produce rotation, just you need to apply it in a different way. So then you understand that okay, so for rotation, force is important, one first thing, and the second thing is point of application of the force, or the direction of application of the force, you can say, or the point of application, where you are applying, in which direction you are applying. To quantify all these things and name it a single quantity, we define torque. We said that is torque. Now
Sir,
here
we
you can
can,
see, yeah,
sir, either
yes,
we can say the force and the angle at which force is applying also we can say important. Then point of application angle will be somewhat it gives some clarity now, sir.
angle between what?
Sir, the radius vector and the point application of force direction. I can say.
Yeah, yes,
Because it can go the direction also, no, sir.
yes,
That can you say it is more clearer than before definition.
yeah, that's it, said that where you are applying the force. And So it's not only the force, but where you are applying the force. And then to make it more precise, then you can say that, okay, it depends on the angle between the, it depends between the force, it depends upon the that position vector, and depends on the angle between the force and position. So all this information that to rotate, है ना, to produce a rotation of this body about this point, or about an axis passing through this point, है ना, there should be a torque about this point. We will have to produce a torque about this point, then only this body will rotate. And that torque depend on so many things, that in words, if I will start saying that, I will say force, where the force is acting, angle between them. So to convert it into a single quantity, we directly say torque. So torque is just the combination of all these, that force, this r vector, and it takes care of everything. So if torque is there, there will be rotation. If torque is not there, there will be no rotation.
But although
What
the
is torque?
rotation will be in terms of angular velocity, we can say in the direction of angular velocity.
No.
Sir, rotate a body can rotate only if angular velocity is present. No, sir.
So here, yes, a body, but the problem is that uh, when I said that uh, there is a torque, then the body will rotate. Okay, so body will rotate. That word itself means that, yeah, it will have some angular velocity. Are you getting? So, but that is not the correct definition. I am saying that here because the body is starting from the rest. So just like you cannot say that, so for example, a body can rotate and keep rotating without any torque. That's why we cannot define it like this. Are you getting? So torque is not required for rotation, just like force is not required for moving with uniform velocity. Are you getting? But why I am saying right now that if torque is there, there will be rotation, because initially there is no rotation, rest, and then torque will be there, so there will be rotation. So actually, I'm not saying rotation. I'm talking about not angular velocity, angular acceleration, change in angular velocity. Initially rest, and then when torque is there, there will be rotation. Initially rest, now rotation, means change in angular velocity, not angular velocity. Are you getting? Means whenever torque will be there will be angular change in angular velocity, means there will be angular acceleration. Alpha has nothing to do with angular velocity. Are you getting? Just like force has nothing to do with velocity. Force has to do with acceleration, right?
Yes, sir.
In the same way, it is not about rotation, it is about the change in a rotation. Means earlier it was at rest, and now it is coming to rotation. To bring a body from rest to rotation, or rotation to, or change its angular velocity, either increase or decrease, torque is required. So torque plays exactly the same role as played
Yes.
by the force in translational motion. So here now you can write the equation that, okay, torque vector
Sometimes
is
directly we can say, sir, since in linear motion, the direction of force is along acceleration, no, sir. So we
that
can
is a
say the
different
direct.
thing. That's a different thing, because that is linear motion. So yes, and yeah. So what you want to say?
So then we can say the direction of torque is along angular velocity,
No.
along angular acceleration. We can say, sir.
Yes. 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 Along angular acceleration. But then the angular acceleration can be deceleration also. Are you getting?
Yes, sir.
So, and at that time it will be, so you have to understand, just like the relationship between force and acceleration, same relationship force. Keep asking.
Sir, sir, in the either variables that this is the directions of perpendicular motion in the circular motions or in angular motion. Sir,
In
if
the circular
we
motion, which direction you are saying are perpendicular?
sir either angular acceleration or angular velocity perpendicular to as per cross product we take no sir.
Perpendicular to what?
So the plane of rotation we can say.
Yes, plane of motion. Yes.
It's motion yes, sir. Sir, we are taking this direction as per the formulas and as per the definition or you can explain it any significantly, sir, maybe with examples can you say, sir?
For what?
Suppose,
Not getting.
so
Yeah.
means generally we say angular velocity is perpendicular to plane of rotation, no, sir.
Yes. That is how its direction is defined.
Sir, but the body is rotating along the plane means the velocity should be also along the plane only, no, sir.
So
Just,
velocity is along the plane, and that is linear velocity. Yes,
but
velocity is along the plane, and that is linear velocity of the particle. Body is not going anywhere in the horizontal, no? So how we can say in plane body has no motion, no? Particles of the body have motion. So particles of body have linear velocity. But angular velocity is not for the particle, it is for the whole body. And the whole body is not going anywhere in the xy plane. For example, fan is there. Fan is not going anywhere. Fan is fixed in the room, right?
it is fixed in the no, sir.
Fan is not going anywhere. So angular velocity of the fan. So angular variables are defined in such a way. You cannot define it any other way. Yeah, that will be not be logically correct because there is nothing moving in the plane. In the plane, you say the particles are moving. Yes, particles are moving. So particles have linear velocity in the plane. But you start talking about angular velocity. Now, angular velocity is for the whole body. Or angular acceleration is for the whole body. Why it should be in the plane? In the plane, there is no motion of the whole body. Yes, if suppose whole body is moving and rotating also, then the whole body will have a linear velocity, velocity of COM, center of mass of the body. But that will be again linear velocity. Angular variables are defined in a direction perpendicular to the plane of motion because that is the only unique direction in which you can define. Otherwise, you tell me which direction you will take. Suppose a body is moving in XY plane and you are saying that the direction of angular velocity, why it is not in XY plane, why it is along Z axis, because there is no, that is the best way to give it a direction because that can uniquely define the, because there is no other way in which you can uniquely define. If you will say that in XY plane, I will take the direction of angular velocity. Now, XY plane, which direction you will take? Are you getting? You tell me, I will accept it. Which direction you will take? A body is there, and this is the axis. Imagine. So imagine the axis going perpendicular like this, and the body is rotating about the axis. So body is rotating about the axis. Now you are saying that rotation is there in XY plane. No, first of all, you can call it the plane of rotation, but because the particles are actually moving in XY plane, particles are not moving in Z. So then you are saying why there is velocity in not in XY plane. Velocity is there in XY plane. That is the velocity of the particle, linear velocity. Every particle moving with different velocity, no? But when it comes about the angular velocity, you say angular velocity. Angular velocity you cannot take in the plane of the motion. You'll have to take it along the axis because body can rotate about an axis only in two ways, either clockwise, anti-clockwise. Then how you will describe the direction in the plane of the body? Body is not going anywhere. Angular motion means what? that it is just changing its
Rotate.
orientation by some angle.
Yes,
Are you
sir.
getting? The body just changes orientation by some angle. So how is to describe that there is some change in orientation per unit time? You know? Then this is the best way. There you cannot do like any other way. So this is the direction. That's why this is the direction of the angular velocity, uh, which is correct. This gives you an idea that okay, body is uh, plane of rotation is xy, direction is along the axis of rotation. So now here this is the torque. Okay, this is the direction of angular velocity or angular. Now here you have to understand the direction of angular acceleration will be in the direction of the torque. Okay. Now here you can see the unit of torque is very easy because it is RF sine theta. So RF. Okay. So this is the unit Newton meter. This is the dimension. Now couple of force. Couple simply means a pair. A couple of force simply means a pair of two equal and opposite force acting at two different places. Equal and opposite force not acting at the same point, acting at two different po- points on a body. So what is couple of a force? So couple of a force is simply two forces of equal magnitude acting at different points on a body in opposite direction, not acting at the same point. If they act at the same point, then that is not called as couple. Now the next is moment of couple. Moment of couple means torque due to couple. Actually, that you know, torque is also called as moment of force. So here now we are talking about moment of the couple. So moment of couple is torque due to a pair of forces. Okay. Now here you have to understand that look at this diagram here. And what is the net force on this body? Net force is zero. But can the body rotate or not? Tell me.
It is rotating.
It can rotate, but can the
Yes.
body translate?
Also, it cannot run.
Why?
So because there is no component of horizontal direction.
So not component of force is not required for translating. The question is not correct. I should ask that can there be any linear acceleration? That is the correct question. And then you should say that no, there cannot be any
No,
linear acceleration. But the body can be moving. Are you getting? Newton's first law. Not required. Force is not required for motion. Are you getting?
yes, sir.
So yeah. So this is a couple. The body and a linear acceleration of the body will be zero, or you can say linear acceleration of the center of mass will be zero, but there will be a torque. Okay. So here you can only say center of mass of the body will have zero acceleration. Individual particles will have acceleration or not?
Individual particles may also, but total can be zero also.
Yes. Total, when you are saying, so you are talking about the acceleration of the center of mass of the body will be zero. Okay, now here you know that these forces can rotate the body. So there is a torque, because of this couple. That torque you can calculate just by using the formula that we discussed. For example, to calculate torque, first of all, you need to select a point or you need to select an axis about which you are finding the torque. Till now, we have learned only to find the moment of torque due to a force about a point, and it is given by R cross F. So let's take any point. So let's take this point. Anywhere you can take. Suppose the body maybe hinged about, or if it is not hinged, it will rotate about its COM. So about its COM, you can take this is the point, and you can find its you can find its torque. So then, let's say this distance is R1. So R1 into F, R1 F sine theta, and let's say this distance is R2. So R2 into F sine theta, and it will be R1 F sine theta plus R2 F sine theta or minus R2 F sine theta. Tell me.
So minus no, opposite
Plus.
direction.
No, not opposite direction. Opposite direction, you are talking about force, but I am not talking about force. Are you getting? I am talking about
Arc.
torque. Torque. I am talking about torque, but you are thinking about force. Force is in opposite direction, but the torque is not in opposite direction. Torque is in the same direction. So both the force will try to rotate the body in the same direction or opposite direction.
In the same direction.
So yeah, also you can check R cross F direction. For both, it will come the same direction. Okay, so then it is simply, and here you can see that I have intentionally taken the F theta as 90 degrees. So it will be simply R1F plus R2F. And now because the F is same couple, so I can take F common and then I will get R1 plus R2. Okay, so it is simply R1 plus R2 into F. Now here you will learn something very interesting. Here you can see that torque due to a couple actually do not depend on where you are calculating this torque. This is only for torque due to a couple. Means you calculate anywhere, any point you take, and always you will get R1 plus R2 into F. Only R1 plus R2 into F, nothing else. You can do it, check it. Take any other point on the body, and couple will be always constant. Sorry, torque due to couple will be always constant. You can take any point. From here, you raised a very interesting property that when net force on a body is zero, then torque about any point will have same value. That is an important conclusion that if you will understand if you
And
can,
why?
if you take in, yeah,
So what happens if net force is not zero? Then the torque cannot be same.
then
With it.
then it is, yeah, then it is not. Then about different point torque will be different. About different point or about different axis. So only in this case they will be equal. Means about any point it will be constant, not in any other case. Okay. Okay. So once you understood that how to calculate the torque due to a force or torque due to a couple of force about a point or about an axis, now we can talk about rotational equilibrium. What is rotational equilibrium? So very simple, just like equilibrium you studied in Newton's law. So at that time, we said that equilibrium means net force zero. But that was translational equilibrium because when net force is zero, body can come from
Rotate.
rest to rotation. Are you getting? Body can have angular acceleration even if net force is zero. So from this you understand that okay, net force zero is translational equilibrium, but the body is not in rotational equilibrium. Because just in the previous question you can see that net force is zero, but torque is not zero, right?
Yes, sir.
Net torque is not zero means body is not in rotational equilibrium. Means rotational equilibrium means net torque zero. And if we say complete equilibrium, complete mechanical equilibrium, we don't say rotational equilibrium or transfer, we simply say mechanical equilibrium. So then it means net force zero and net torque also zero. Now you might be thinking, net torque zero about which point? So about any point.
Sir, in a rotation equilibrium, how can a body be in translation? How can a
Sorry.
body, sir, can a body in rotational equilibrium can move um, in a straight line, sir? Means it can have a translation motion, sir.
Uh,
I mean, if this body is in rotational
yes.
equilibrium and it can move, sir, if we can.
Yes, it can move. I will show you one example here. See, this is the example. So, suppose this is a rod. This is a rod,
Yes, sir.
and here you can see that two forces are acting.
One.
One force is this, and one force is this. Both the forces are equal in magnitude and exactly equal distance from the center. I have just taken one example. There are many possible.
Yes,
This is
understood.
an example which you are talking about, right?
Yes, sir. Yes. Equal magnitude of. Yes.
So here you can see that it is in translational equilibrium, not in rotational. And suppose the body is hinged about the axis passing through its center. So I'm just taking a special situation. Are you getting? So there can be situations where the body is in rotational but not in translational equilibrium, or even if suppose there is no axis, free body, then also you can say this. So because you want to know about the, you know, uh, about the translational equilibrium, so I'm not keeping it hinged. I'm keeping it free. So now also it is free. So it cannot rotate, but it can translate, right?
Yes.
So here you can see that the center of mass will have an acceleration, linear acceleration, ACOM, COM, whereas you can see the alpha COM means angular acceleration of the body about the center of mass is zero. So angular acceleration here you can see is zero, but angular linear acceleration is not equal to zero. So yes, both are possible. Okay.
Sir, at every point, angular acceleration can be zero.
Yeah. So here you can see every point it will be zero. Yes. So if a body is not rotating and if a body is not rotating, है ना, means its net torque is zero, uh, then it should be zero about all the point. Then only it is, you can say it is in rotational equilibrium. Otherwise, it will rotate, no? That body will rotate about some other axis or some other point.
Yes, sir.
Okay. So, so that is rotational equilibrium, net torque on the body, zero. Okay. Here you have to understand that a body cannot be in rotational equilibrium under the action of a single force whose line of axis is not passing through axis of rotation. If there is a single force, its line of action must pass through the axis of rotation. Then only it will be in equilibrium. Otherwise, if the line of action of the force is not passing through the axis of rotation, then the body will rotate.
Sometimes uh, we will fix the body along the axis of rotation and we will try to rotate the body, sir, in every case.
Not getting.
Sometimes if generally if you take a body, sir, generally,
Okay.
sir, if you want to rotate it body, compulsory we need to fix the body at one point, no, so then only
Compulsory.
we need to fix that body, no, sir, at one point.
No, even without fixing, there can be rotation.
Huh.
But then there will be translation also.
Means only rotation if you need, if you want. Means
Only rotation is also possible without fixing. When net force is zero, right?
fair enough, proper.
Net force is zero. But yeah, so mostly only rotation means that the axis is it is fixed about an axis. If it is not fixed about an axis, the body will rotate about its COM, but then it can also translate. To
So,
you can
but
make, yeah.
so if you take a rod, sir,
If you take a rod and the forces acting on the rod are equal and opposite and perpendicular to the rod at all the time. Perpendicular to the rod all the time. This is very important. This and this, they are always perpendicular to the rod and equal magnitude. Now you can see there will be, and there is no, it is not hinged. You can see there is only rotation, right?
yes,
Always perpendicular, I'm saying. Are you getting my point?
sir, I'm getting.
So ACOM will be zero. So not always, but I have put some conditions in. I can make some conditions where there will be only rotation even without friction. But the condition is that the net force should be zero at all the instant. Then it is possible. Okay, now next. Next is bending of a cyclist on a horizontal turn. So you can understand that when you are cycling in your early days, you might have realized that, you know, when you start cycling, sometimes you fall, and then you know that there is a you will have to drive your cycle at a particular speed. Then only it will be balanced, right? If
Yes,
you
sir.
to if you try to take a circular turn and you decrease the speed, a moment will come when it will just fall. The cycle will fall. Cycle cannot be in rotational equilibrium if the speed is very very low. So here you can understand, suppose this is a, can you see the cyclist, a person is, boy is cycling,
Yes, sir, I can see.
and here the wheel is touching the floor. So here you can see that a normal reaction force will act on the bicycle at this point, like this, and then there will be friction force also which will be acting towards the center, like this, frictional force. And now think about mg. Mg acts at the center of mass here. Now if you look at all the forces, okay, so just imagine that if you will drive very slowly, what will happen? What will happen is the cycle will rotate about this axis and will fall like this, right? See this, it will rotate like this and will fall. It will rotate and fall. Right now it is tilted at some angle with the vertical, right?
Yes,
Why it is not falling right now?
you have balancing of forces.
So here you have to understand that the boy is not at rest. First of all, the boy is accelerating. So if you sit on the cycle and then you see that the cycle is in rotational equilibrium, but you are sitting on the cycle, so you have to take a pseudo force, and that will be opposite to the direction of the acceleration of the cycle, pseudo force, mv square by r in this case. And now suppose you are sitting on the cycle, observer is sitting on the cycle, What observer is saying? That the person is in rotational as well as translational equilibrium. Because when you are sitting on the cycle, you see that the cycle is at rest, first of all. So net force on the cycle plus cyclist must be zero. And second, you are saying that the cycle plus the cyclist is not rotating about any axis. Net torque will be also zero, should be also zero. Net force zero, net torque zero. So if you just write the equation, take the not net torque about any point, but you will choose the points wisely. So because here normal reaction and these things are not known, so you take a friction, you know? So you take this point of contact of the cyclist with the road, and about this point, if you want to find the torque due to all the forces. So here, this is your mg force. There will be torque only due to two forces about the point of contact. About the point of contact, there will be no torque due to friction and no torque due to normal reaction, because friction and normal reaction both are passing through that point. So because these two forces are passing through that point, R became zero. Are you getting? R cross F, R became zero. So there cannot be any torque due to normal reaction and friction about the point of contact. So then you just have to balance the torque due to mg and mv square by r. Why we are balancing? Because you can see that their torque due to mv square by r is trying to rotate the cycle is in this direction, whereas torque due to mg will try to rotate it in this direction. They are in opposite direction. But the cycle is not rotating, means their torque must be equal in magnitude. So just equate their torque, you are getting this condition. So you can see cyclist can bend only up to this angle for a given speed. If he bends his cycle by some greater angle, suddenly torque due to mg will increase and it will become more than torque due to mv square by r, and then the cycle will rotate and will fall. Are you getting? So finally you got this result tan theta equal to v square by r, where theta is the angle by which the cyclist is inclined with the normal to the road, with the vertical. So in this you have any doubt, you can ask.
Sir, no doubt, sir.
Okay, so then we'll go to the next. Okay, now next is toppling. So before toppling, let's try to do some questions. So you can try this question. I will give you the diagram also. Try this question. And you can ask any doubt if you have in concept. Just tell me the equations. Just write down the equations and tell me the equations. That's it. Do you know Himanish Pravakar?
Yes, sir.
How you know Himanish?
Sir, through group only, sir.
Okay. So, and you are sharing your ID with him, that Geo meeting?
Sir, what? First, sir, through Telegram group, that guy only referred your name, sir, through Philo.
Okay.
In Telegram, there is a group, sir, for uh, students.
Okay. Okay.
He only preferred your name to take class.
Okay, got it.
From there,
Hmm. Okay. Try this question. Just tell me the equations that you will write to find the tension. So here you can see in this situation, the rod cannot rotate, and in this situation the rod cannot translate also. Okay, got it.
just 1 minute.
Okay.
So I'm getting the question. So we can say here both translation and rotation equilibrium will be now, sir.
Yeah, yes, translation and rotation equations.
Let's see. Let T1 plus T2 600, sir.
Correct. then
For rotation, sir.
then what is the equation?
So then 400 minus 400 into L by 4 minus 200 into L by 2 plus T2L equals to 0, sir. For rotation equilibrium. About
uh,
point
again
K.
again again can you repeat?
So applying about point K, sir.
Okay.
400 into minus L by 4 minus 400 into L by 4 minus 200 into L by 2 plus T2L equals to 0.
So both you are saying minus.
So both minus and change.
If both minus, then you will get negative, no? Why you are saying both minus? Look at the torque.
Yes, sir. At
Torque,
point
this force
B,
will try to rotate it this side, right? Whereas this force will try to rotate it this side.
so plus minus it will be, sorry.
So plus minus, no?
Yes.
Okay. Both not minus. Plus minus. Okay. So that is correct. And you can try this one. Try this question.
Yes, I'm trying, sir.
Hmm.
Sir,
Yeah, tell me.
it will be 100 rad per second, no, sir.
Okay, so just tell me the equations.
Sir, usually we can apply torque equals to I, al- I
Okay,
alpha, that will be tension into perpendicular distance we can apply now, sir.
that is correct. That is the answer. 100 is the answer. Correct. Okay, so you can try this one. It is easy.
Okay.
Just tell me the equation. We'll go to the next one. Got it.
So now this is
You can just tell me the equation. The equations that you are using to solve, while solving, you are writing some equations. Just tell me those equations.
Okay. The equations will be first your I'm figure outcome I get mg minus p will be square mean also.
Correct. Then,
And then
but how you will find t? Yes.
the net torque will be T into R now, sir. It is equals to I alpha, we can equate now, sir.
Correct.
Moment of inertia is given now, sir.
Yeah, correct.
And tension will get and pressure volume is and the value.
Yeah. Okay. So,
The moment of inertia, this torque is vector or scalar.
sorry.
The torque is a vector or it's a vector only. No?
So, what is the formula of torque?
Cos from the
What
vector.
is the formula?
Vector product of force is F or sin
Yeah. Vector product. So, vector product always gives vector.
vector.
It is a vector quantity. That's why we were talking about its direction is perpendicular to the plane of rotation, plane of motion. Because it is vector, then only it's have direction. Okay, so after this we can go to some other. Try this question. If you have already tried, then you can tell me. I'll give you another question. Have you already tried this question? Not tried, then you can try. Are you there?
I can use level.
Okay, try. Just tell me the equation.
Sir, torque will be mg L by 2 now, sir.
mg into.
About A, sir, torque will be mg L by 2 now, sir.
Yes, correct.
Then the torque is I alpha now, sir.
Yeah.
From comparing we get is L alpha, we get 3g by 2.
Yeah, 3g by 12 is the correct answer. So simple. Try this question.
Um,
Which option?
The first option and fourth are same now, sir. A and B.
First and
The fourth option, sir. Fourth option.
no. Look carefully.
Okay, sir.
D is the correct, right?
It's a D and change. Fourth option is correct.
Yes. Try this one. कोई visitor request आया है? कर दे। Got the answer, Prabhakar? Are you getting, not getting?
अरे यार फालतू
Yeah, you can ask. What is your problem? What is your doubt?
sir t equals to 2 seconds only. One second.
Okay, so what is the concept here? What you did?
Sir, sir, since we given we found it by differently looking at the instantaneous angular position. Okay, sorry, sir.
Alpha equal to 0.
Sir, if the alpha found is equal to 0, then we can get it.
Yes. So it is not equal to 2 seconds, it's equal to 1. Are you getting?
Yes, sir. Yes, I'm getting.
What you did is wrong. Yeah. So careful. Okay, so just keep trying solving these type of questions. And today we covered the basics. Like from tomorrow we can do some good level questions. Okay.
Yes, sir.
Okay then. All the best.
Thank you, sir.
Bye.
Thank you, sir.
Okay, bye. All the best.